Hello, everyone. It's my great honor to talk about our paper accepted by Inner Speech 2021. My name is Shijing, and the paper I'm going to talk about is Speech2Video, Cross-Modal Distillation for Speech-to-Video Generation. Here, I'm going to quickly walk you through this paper and now let's begin. So this is the overview of my talk. So firstly, I'll give you a brief introduction of the research background, and then I'll talk about the methodology, and then we'll go to the experiments and show the performance. Okay, firstly, I'll talk about the motivation of this work. So basically, speeches are audio signals that carries affluent information of video of various domains. Like if I give you if you hear my speech, you'll very likely know that I'm a man. I'm a man, and you could also get some information like my possible age, So people can get a lot of information from speeches, especially if you are familiar with a group of people. Then it's very likely that after you hear a person's voice, you can imagine your head will get the idea of what that person looks like. So this is what human can do easily. So in this work, what we are trying to do is we are trying to generate a talking face video solely from speeches. Basically, human brain can extract information from a single piece of speech and recall or form imaginations of the identity of the potential speaker and his or her facial movements. So what we try to do is, here is the figure. There are so many lines of research in this area, and very often people have tried to use a photo of a person and a video, and then they generate a talking face with that photo. So this is a video-to-video generation task. And also, another line of research in this area is if you are given a photo and the audio and a piece of speech, you can generate a talking face with that person and a specific piece of speech. So this is like speech-driven animation task. In this work, what we're trying to do is the third one, which is you are given a piece of audio and you want to generate that specific person, what that person look like, and his facial movements when he talking about when he give that speech. So this is what we are trying to do. Basically, we want to generate a talking face solely from a piece of speech. So here is our framework, which is called Face-to-Video framework. Basically, our framework can be divided in two parts. The first part is in the left-hand side, and the second part is in the right-hand side. The left-hand side tries to do is to disentangle information from the input speech. So this area is the teacher of emotions, and this area, this part is the teacher of identity. Here, we try to teach the model to master the ability of emotion and identity generation. So we disentangle, we feed the input speech into a encoder network, which is done by CPC, and we get the last feature, and then we do a feature disentanglement, and we get the emotion encoder and the identity encoder. So this can be done in an unsupervised way. So if we have a talking face video, and you can get the input speech here and the visual information here and here, and then you can train this model. And the right-hand side is about the generation. Here, we input the new and mu. New is just the identity information. It is the feature of the identity information. And mu is the emotion information feature. And and also we get the CPC feature at different frame, T frames, from the input speech. And then we try to generate the talking face of this person by this network. So here are a few loss functions we use that you can find more details in the paper actually. And so essentially we'll need a multitask distillation loss, which is essentially a cross-modal loss between the teacher model and the student model for disentanglement, for feature disentanglement. And also we have the adversarial loss, which is a least square gain loss. We get this from the literature. And also we have the frame similarity loss, which is a pixel-wise similarity loss imposed on the generated frames, which is corresponding to the input frames of the speech. And we have the gradient loss to alleviate the blurriness caused by our one frame similarity function. And for the experiment setup, here is some basic information. Here we use a few datasets called the crowd-sourced emotional multimodal actor dataset and the Fox slab 2. And we have the baseline methods called speech-to-face and SDFA, and also the F2F plus SDFA model. Here is the qualitative performance of our methods. So there are two plots in this figure. The upper one is a black female that is saying this is exactly what happened in an anger emotion. And the first row is the ground truth talking face. And the second, third, and last row represents SDFA method, F2F plus SDFA method, and our method. We can see that basically our method performs quite well, not bad than others. And in the lower panel is a white female saying who create all of the goals in a very happy emotion. We can see our method performs the best better than the baseline methods. Here are the quantitative comparison of our method, and the metrics here are the SSIM, PSNR, and confidence score. We can see that our method is comparable with other methods, but we only need the audio. We only need the audio input. Yeah, that's it. Thanks everyone for listening.